Good morning, guys. All right, so today, unfortunately, I am out, so I went ahead and made a video for the lesson. So if you have not done so already, make sure that you download this and then pull it up to the side so that you can take notes and follow along as I go through the notes for you. At the end of today, the expectation is that you will do this cool down on your own. I'll provide the answer key for it in our Canvas page. And then lastly, you'll finish up the practice problems here, 1 through 4, submit those back into Canvas. I'll check them off and mark them as correct or wrong. And then I'll talk about them on Tuesday when I return. So let's go ahead and get started. We have writing equations to model relationships. All right, so this is going to be a 2-day affair. And like I said, we'll kind of recap it tomorrow as well. But first, I want you to start with evaluating each of the following mentally. So I want you to take a moment. Pause the video if you must, but I want you to see if you can think about what these amounts would be off the top of your head and about what you would do to figure that out without a calculator. So go ahead and pause that now. Okay, so if you've done that, hopefully you have a good idea of how to do this, but if not, I'm just going to talk to you about one strategy that might have been employed. You may have chosen a different one, and that is okay. But when I look at percentages of a number like 200, I try to make it a little bit simpler by using some numbers that make more sense to me. So for instance, 200 is a multiple of 100, right? And I know that percentages are being moved 2 places. So for instance, 25% of 100 is really like saying 25 out of 100. Right? And so if it's a multiple of 100, I can then just multiply both of these by 2, and that tells me that 25% of 200 is really just 50. Okay, so that same idea, of course, applies to the other ones as well. So if you have 8% of 200, one way you might have thought about this is, what is 8% of 100? Well, it is 8 out of 100. And then, since it's out of 200, you double that number, and that becomes 16. Okay, same thing for 12. So once you start getting kind of the hang of this, feel free to apply this in the store when you try to figure out how much is off of a $200 bill, right? If you're doing beginning of the year clothes shopping or something like that, you could maybe help out your parents with this. But 12% of 200, so we know that out of 100, it would be 12. Multiply that by 2, and that's going to give you a total of 24. Again, you could do this differently. This is just one way of doing this. So what percentage of 200, whatever it may be, since these other ones, it was all double that initial percentage, right? 25 times 2 gets you 50. 8 times 2 gets you 16. 12 times 2 gets you 24. So we could just say that P percentage of 200 is going to be the same as 2 times whatever that percentage is. Okay, so our strategy here was basically thinking of it like, what is it out of 100? And then doubling it. Okay, and I do the same thing too. Sometimes when it says, like, for instance, what is 40% of $40? Right? Let's say I want to take 40% off of a t-shirt that's $40. Okay, well, I would try to give it to a multiple of 10. So instead of thinking of 40, I'd say, okay, well, what's 40% of $10? Well, that would be 4, right? Because 4 out of 10 is 40%. Well, that's a multiple, so I can multiply that by 4, both sides, and that's going to get me to 40. Excuse me. So that gives me 16 out of 40. So that's $16. If it told me it was 40% off, I would take off $16 from my $40, which would leave me with like a $24 shirt, something along those lines. So that's how to quickly do math off the top of your head. You should be able to do 4 times 4 and just think of it out of 10. Okay. So last week we did pizza party plans, right? And we talked about the different costs of pizza. So we're just going to go through an example here. Let's say that we multiply cost per pizza by the number of pizzas, all right? So if $10.99 is how much it costs per pizza, so for one pizza, if we wanted to figure out how much the total would be, we'd have to multiply it by the number of pizzas that we we intended to buy, excuse me. So $10.99 times, let's say, 3 pizzas, right? Well, n in this case is a variable. I know you guys have gone through this before, but it's a letter or symbol that represents an unknown number or quantity. So we're going to use all different kinds of variables this year, right? So right now, what I want you to do is we've got, let's see, 1, 2, 3, 4, 5, 6, 7 different questions here. The top ones are all about blueberries, but then the bottom ones are about earnings. I want you to pause the video and either talk to somebody around you or try to do this independently if you would prefer. And you're going to try to write out an equation to represent each situation. So remember, an equation is something with an equal sign. So it might look like this. It might look like this. Okay, or you might use other variables, right? So go ahead, pause the video and see how you do, and then I'm going to show the answers. Okay, so blueberries are $4.99 a pound. Diego buys B pounds of blueberries and pays $14.95. All right, well, we know that they're $4.99 a pound, $4.99, and he buys B pounds, so it's going to be $4.99B, and the total is going to equal $14.95. So that was the equation for the first one. Okay, second one changes it up a little bit. Now they're saying that Jada buys P pounds of blueberries, so we're changing the variable here, and pays a total of C dollars. So now we don't know the total, so that means we have 2 unknowns, and we actually wouldn't be able to solve this even if we wanted to without some more information. So we have $4.99 P for Jada, and then C is the total cost. Okay, and then lastly, we have one more here, which this one has 3 different variables. It's got D, Q, and T, which really means we can't solve this until we get some further information, right? So blueberries are D dollars a pound. Lynn buys Q pounds of blueberries, so the cost by how many pounds, and pays a total of T dollars. So that equation would look like that. Okay, and again, if we know that blueberries are $4.99, we can substitute it in here. If we know how many pounds are being purchased, we can substitute it in here and solve for T, or vice versa. As long as we only have one variable, like this equation, we can solve it. All right, earnings. Noah earned N dollars over the summer. Mai earned $2.75, which is 45 more than what Noah did. Okay, we haven't really talked about more than like this, but Noah, right? Noah is N dollars. So we're going to use N for Noah. Mai earned $2.75. So let's say that Mai is $2.75. And if they both purchased the same amount, then the equation would look like this, where it'd be like Mai is $2.75 and Noah is $2.75. However, we know that's not the case. We know that Mai earned more than Noah. So this 275 is going to be more than Noah. So this equation was really N plus 45 gives us the 275. So whatever Noah earned, add $45 to that, and that gets you to Mai's total. Maybe it's May. Noah earned V dollars over the summer. May earned M dollars, which is $45 more than what Noah did. Okay, so now we don't know what May earned, but it's going to be the same type of formula. M, only V now for Noah, and 45 for our unknown. Okay, Noah earned W dollars over the summer. May earned X dollars, which is Y dollars more than Noah did. Same thing, only this time May is X, Noah is W, and we don't know how many more dollars it is, but we can plug in a Y. And so then it asks, how are the equations you wrote for the blueberry purchases like the equations you wrote for Mai and Noah's summer earnings? How are they different? Okay, so if we look up here, pretty similar in that we ended up using 3 variables apiece. So more variables as we continued. But also, the blueberries were multiplying, whereas the earnings were adding. So I'm just going to put that like this. Multiply versus add. Okay. All right. Let's do one last activity here. So almost done. It says, Congratulations, you're buying a new car. Use the information below to determine the total purchase price in each scenario. By the way, buying a car is not fun. The amount of negotiating and everything else, it's one of my least favorite things to do. The total purchase price of your car is a combination of original car price, sales tax on the car, and an additional charge for miscellaneous items such as, tax, fees, whatever, insurance, whatever it may be. A sales tax on a car in Ohio is 6%. To determine how much tax you owe, multiply the original price by 6, which, by the way, much more now, 7.5. The additional charge is $120. So, it wants to know how much the total price would be if the original car price is $950. Well, we know that the total price is going to be the original car price, let's call that X, the sales tax, Y, and an additional charge, Z. Okay, so to determine how much tax you owe, multiply the original price by 0.06. Okay, so if the original car price is $9.50, well, then that means the sales tax on the car, right, is going to be this Y value, but we don't know what that is until we multiply by 0.06. So let's take 9,500 and multiply it by the sales tax, which I'm going to use a dot here, times 0.06. Okay, I don't know what that is off the top of my head, so I'm just going to use my calculator here. 0.06 times 9,500. We could try to estimate that, right? But there's no need to if we're trying to get an exact price. And that's going to be $570. Okay, so to figure out the total cost, we know the original price is $9,500 plus $570 in taxes plus an additional charge, which it states up here is $120. That's probably tax and title. Okay, and so the total cost of that car, $9,500 plus $570 plus $120 gives you $10,190. Okay, next one says if the original car price is $14,699. So same idea, right? $14,699 plus blank plus the additional price of $120. Okay, well, what is that blank? It's going to be that price, $14,699 times 0.06. Okay, 14,699 times 0.06 gives us $881.94. Add that to 120, add that to $14,699, and we're now talking about $15,700.94. So you can see this is one of the misconceptions about a car. Sometimes when you go to buy a car, you see a price in the window and you think, oh, it's $9,500. That's what it's going to cost me. And then by the time you pay for tax and title and all that other, it ends up a little bit more that you either have to finance or have out of pocket. Okay. What if the original car price is P? Well, how could we solve that? All right. Well, we don't have this anymore, and we don't know what this is, but we know how to calculate it. So let's say the original car price is P. We're going to change that for the first letter instead of X. Then how do we find the sales tax? Well, we take the original price and multiply it by 0.06. So we're plugging that in. And then lastly, we have our additional charge, which is 120. So once we find P, we can plug it back in and do the same thing we did in the first two. What if the original car price is P and additional charge is M? Okay, so now let's say that tax and title is a little bit more. We don't know how much it is. So instead of writing down 120, we're going to use the letter M. Okay, because it might be $300. It all depends on the dealership and what hidden fees they potentially have. Okay, so that's kind of it for today. I want you guys to go ahead, like I said, and do this cool down. I'm going to post an answer key for that here just momentarily. And you can check it over with your friends around you if you want. And then lastly, do the practice problems. Make sure to submit those into Canvas. Again, I apologize I wasn't there today, but I'm looking forward to seeing you guys tomorrow and seeing how you did.